Hey everyone, we are starting today with a moment that has just passed because only hours ago, 3I Atlas completed its closest approach to Earth. This was the point where distance, geometry, and perspective were changing at their fastest. And that timing matters, because what we observe immediately around closest approach often reveals behavior that stays hidden at larger distances. This was not a theoretical milestone, it just happened. During closest approach, Earth's relative motion against the object's trajectory accelerates the rate at which our viewing angle changes. That makes this window uniquely valuable because subtle structural effects become exaggerated and easier to separate from noise. And what became clear during this window did not come from a single image or a single observer. It came from consistency across nights. This is not about one frame. This is not about one telescope. This is about geometry unfolding in real time. Over 3 consecutive nights of enhanced imaging, 3I Atlas displayed a clearly defined antitail. Not a faint extension and not a diffuse glow, but a structured feature that remains visible night after night. The antitail is coherent, attached to the coma, and stable in brightness. What makes this observation important is not simply the presence of the antitail. It is how rapidly its orientation changes. Night to night, the antitail rotates through a noticeable angle. The directional change is fast, far faster than what is typically observed in solar system comets that are gravitationally bound to the sun. In bound comets, tail orientation usually evolves gradually as the orbit curves and solar radiation pressure changes. Here, the change is compressed into a much shorter time span. And this is where verification matters. The background star field remains fixed across all 3 nights. Stars hold their positions relative to one another. They do not rotate, they do not drift, and they do not smear. The only thing that changes is the orientation of the antitail relative to those fixed stars. That single detail confirms this is real geometry, not tracking error, not processing variance, not visual illusion. Now let us slow this down and look at the spatial context more carefully. When geometric diagram overlays are applied and aligned to each night, a clear progression appears. On December 18th, the antitail is aligned low along the orbital plane. On December 19th, there is a measurable angular shift. By December 20th, the antitail has reoriented strongly toward a new position that cannot be reconciled with a flat 2-dimensional explanation. This progression confirms that we are seeing a 3-dimensional perspective effect, not a physical tail whipping around the nucleus. This is not random motion. This is not turbulence. This is geometry revealing itself as Earth moves. And the reason this happens comes down to how 3I Atlas is traveling through space. 3I Atlas is on a hyperbolic trajectory. It is not gravitationally bound to the sun. It is entering the solar system at a steep inclination relative to the ecliptic and moving with high excess velocity. That combination produces a rapidly changing viewing geometry from Earth, especially during closest approach. In simple terms, we are not watching a tail swing around an object. We are watching Earth's line of sight slice through an interstellar dust plane. As Earth, the object, and the Sun move relative to one another, our viewing angle changes quickly. That rapid change causes the apparent rotation of the antitail, even if the dust itself is distributed along a relatively stable plane in space. This is why the rotation appears dramatic. This is why it accelerates around closest approach. And this is why the effect is so rarely observed with this level of clarity. Now let us talk about composition clues, because the images are telling us more than just geometry. Enhanced imaging reveals a dense and luminous coma surrounding the nucleus. The brightness is concentrated and controlled rather than explosive. The coma does not show signs of violent fragmentation or chaotic shedding. Instead, it remains compact and well-defined. At the same time, the ion tail response appears weak. Instead of strong ion-driven features stretching outward, the structure is dominated by large dust grains. Larger grains respond more slowly to radiation pressure, which contributes to the stability we are seeing. There's also a subtle greenish tint in the coma, consistent with diatomic carbon emission, This matters because it suggests material that has not been repeatedly processed by close stellar passes. Repeated heating cycles tend to drive off more volatile compounds early. Here, the signal suggests relatively pristine material. In other words, this looks like extrasolar material encountering this environment for the first time. Now place this behavior alongside what we know from previous interstellar visitors. The first known interstellar object showed no coma and no tail at all. The second behaved like a more classical comet, with familiar tail structures driven by solar heating. 3I Atlas does not fully match either case. Instead, it combines a rotating anti-tail driven by geometry, a stable dust-dominated coma, and weak ion response. That combination makes it one of the most informative interstellar objects observed so far. Very few interstellar objects have been observed across multiple nights with this level of geometric clarity, and even fewer during a closest approach to Earth. And this is why these observations matter. They help scientists refine models of interstellar dust dynamics. They help improve understanding of extrasolar comet composition. They provide a real-time demonstration of three-dimensional orbital plane interactions. And they help distinguish true interstellar objects from long-period comets originating in our own Oort cloud. Now, briefly, we need to address something else that circulated around the time of closest approach. A narrow frequency signal was reported in Earth's Schumann resonance data near 25 Hz, close in time to perigee. Signals in this range are rare and differ from broadband atmospheric activity such as thunderstorms. It is essential to remain disciplined here. Temporal coincidence does not establish causation. Earth's electromagnetic environment is complex, and isolated signals require careful statistical study before any connection can be evaluated. What can be said responsibly is this: the signal was narrow, it was isolated, and it was uncommon. That makes it a data point worth documenting, not a conclusion to be drawn. This careful approach aligns with what Avi Loeb has emphasized in recent commentary on 3I Atlas. When observations do not fully match expectations, the correct response is not dismissal and not speculation. It is careful documentation and model refinement. Anomalies are not answers. They are indicators that classification may be incomplete. 3I Atlas appears to ignore Earth entirely in a physical sense. Beyond gravity, there's no sign of interaction, no disruption, no response. It continues along its trajectory, governed by momentum, geometry, and initial conditions set long before it entered our system. And that by itself is informative. What we are watching is not just an object passing through. We are watching interstellar geometry unfold in real time. We are watching extrasolar dust respond to a new star. And we are watching how perspective can transform structure without changing material reality. This anti-tail rotation is not an illusion. It is not noise. It is not a processing artifact. It is three-dimensional interstellar motion revealed by a rapidly changing vantage point. We do not need conclusions today. We need continued observation. We need careful comparison. And we need patience. Credit matters, raw data matters, geometry matters. This is how space is actually studied, not through certainty, but through consistency. Let me know which part of this closest approach evolution stands out to you the most. And if you are following 3I Atlas as it continues through the inner solar system, stay with it. The geometry is still changing and the data is still coming in.